Assalamualaikum everyone. Today we are solving Physics Unit 4, January 2019 paper. Let's start with section A, number 1. Which of the following units is equivalent to farad? Farad is a unit for capacitance, which is Q divided by V. Now we're going to write the units for them. For C is farad, as we know, and for charge it's coulomb C, and for voltage it's V. If you rearrange them, it's gonna look something like this. We have this option in number B. Next one, number 2. A potential difference V is applied across two identical capacitor of capacitance C connected in series. Which of the following expression is the total energy stored on the capacitor? First, we're gonna draw a series circuit. Two capacitors in a series circuit. This is negative, this is positive. As we know, voltage is shared among in a series circuit. So we're gonna write V by 2 for this as well, as they are shared. For the normal formula for energy stored in a capacitor is E equal to half CV square. For this capacitor, as we can see, it's half V by 2, so we're gonna include that here now. 1 by 2 C V by 2 square. V square by 4. 8 CV square. As there are two of them, now we're gonna write the total of it. 1 by 2 CV. Oh wait, not this one. We already have it here. 1 by 8 CV square into 2. If we cut them out, it's gonna be 1 by 4 CV square. Where do we have this option? In number B. Number 3. Two parallel conducting plates are separated by distance d. A potential difference V is applied between the plates and a charge Q is placed halfway between them as shown. Which of the following gives the magnitude of force acting on the charge? Now, electric field strength is the force per unit of charge experienced by a test charge placed in a field. So the formula is E equal to F by Q. As we need to find the force acting on the charge, we're going to rearrange it. E into Q. From electric field strength is calculated by dividing the voltage between the parallel plates by distance between them. So it's gonna be E equal to V by D. We're gonna put this value in this E. Now which will be V by D into Q. The option is number D. Number 4. Current carrying wire is placed perpendicular to magnetic field of magnetic flux density 0.05 Tesla. The length of the wire in the field is 10 cm and the force on the wire is 2 × 10 to the power minus 3 Newton. Which of the following is the current in the wire? As we know, it is perpendicular to the magnetic field, which means theta is equal to 90. So we can use the formula F equal to BIL. We need to find the current. We're gonna make I subject. I equal to F by BL. For force, it is 2 × 10 to the power minus 3. For B, 0.05 into 10 centimeter. We're gonna convert it into meter. Minus 2, which is 4 × 10 to the power minus 1. Option number D. Number 5. Which row of the table shows the quark structures of meson and its anti-meson? First of all, a meson contains one quark and one anti-quark. So it's like two of them. So option C and D are totally out of it. So we're gonna focus on A and B. Let's see number B. It has up and anti-down and up. They both are same, so we can't take number B. So obviously the answer is number A. Why is it A? Because it has anti-up and down, up and anti-down. They both are different. Number 6. A particle has mass 3.4 gigaelectronvolt per c². Which of the following gives mass of particle in kg? First of all, we need to convert it into EV. For that, 3.4 into 10 to the power 9. Then we have to convert it into joules, which is 1.6 into 10 to the power minus 19. As it is per c square, we are gonna divide it by c square, which is 3 into 10 to the power 8 whole square. We have this option in number D. Number 7. The diagram shows the tracks of two particles P and Q created from an original particle at point X. Which of the following can be concluded from this diagram? Option A. P and Q have equal and opposite momentum. They do not move at opposite direction at point X, because if they do, the spiral would have gone downward. So this is not an option. Number B. The original particle has no charge. This can be the answer because they do not have charge. This thing has to be neutral for them to move in different direction. This might be positive and this might be negative. We don't know which is positive, which is negative, but for them to move in a spiral like this, they have to have opposite charges. The original particle was stationary. No, they cannot be in a stationary state because the gamma photon cannot exist in an rest position. The magnetic field acting into the page. We cannot say it's acting into the page because we don't know the charge of the particle because it's not given here. Number 8. The drum of a washing machine rotates at the rate of 1200 rotation per minute. What is its angular velocity in radians per second? As we know the formula for angular velocity, W equal to 2 pi r n by t. Here n is revolution. 2 pi into 1200 divided by 60 because we have to convert minute into second. So the answer is 126. We have the data in option C. Number 9. A body of mass m has momentum p and kinetic energy ek. Which of the following is the kinetic energy of a body of mass 2m and momentum 2p? As we know the kinetic energy formula, p squared by 2m. Let's take that as equation 1. For next one, we're gonna assume it's ek1 equal to, there's 2p momentum, so 2p whole squared divided by, and they have mass of 1, so 2 into 2m, which is 4p squared by 4m. If we cut the 4 out, it will be p squared by m. We'll take this as equation 2. Now we are gonna equal these two equations. So ek equal to ek1 p squared by 2m equal to p squared by m. This all get cut out except 2. So 2 is the ek. So we're gonna have double kinetic energy, which is in option B. Number 10. Electrons can be used to investigate atomic nuclei. Which of the following is not a reason why electrons can be used for such an investigation? Number A. Electrons can be accelerated to a very high speed, which is true. Electrons can have wavelength similar to size of an atomic nuclei. This statement is true as well. Electrons have negative charge. This can be an issue to discuss because it can't just be negative charge, it can be positively charged as well. So we're keeping this in mind. Electrons undergo diffraction. This statement is true as well. So our only option is number C. We are done with section A. We're gonna go for section B in next video.